My name is Fatima Al-Kadhi. I'm a junior psychology major and chemistry minor, and I would love to be an Orgo 2 mentor. A little fun fact about me is that I moved here when I was 10 years old. I was actually born in Baghdad, Iraq. Cool. Chemistry was my favorite subject. I used to stay after school and tutor other students in chemistry because I loved it so much. However, when I got to UNC, I realized that my study habits were not the best. I didn't actually end up doing so well my first semester at UNC. However, I ended up seeking out the help of chemistry mentors who helped me learn better study habits and better strategies to excel in chemistry. I'd love to be an Orgo 2 mentor because I would love to help other students get all the access they needed to do the best they could in chemistry. In the following section, I'll show you all how I solved a practice problem. Thank you!
This problem asks us to show how to synthesize the molecule below and to provide all reagents. First, we can begin by identifying the reaction. This is an EAS reaction, an electrophilic aromatic substitution. Once we've identified the reaction, we can identify the groups attached to the benzene rings. It's also helpful to know whether each is ortho, para, or meta-directing. We know that the Br group is weakly deactivating and that it is ortho, para-directing. We also know that the alkyl group is weakly activating and that it is also ortho-para. However, we can see that this alkyl group did not undergo rearrangement. Thus, there must have been an acylation reduction, and that prior to reduction, we added the following reagents. Now we have to figure out whether we added the acyl group first or whether we added the bromine first. We can see that the bromine is meta to the alkyl group. Therefore, we note that the bromine was added before acylation reduction took place. Thus, the first step was acylation, followed by the addition of bromine. Finally, we know that reduction took place. My favorite reduction is the Clemmensen reduction because it's the shortest. However, if this were a multiple choice question, we'd need to know all of the reducing agents that could be possible. If we're unsure about whether reduction occurred before or after bromination, we can see what would have happened if reduction occurred second. If we reduce prior to adding bromine, we'd note that this alkyl group is ortho-para-directing because it's weakly activating. Thus, after adding bromine, we would be left with the following products. Therefore, we can safely assume that this is the synthesis that allowed us to create the following molecule.